Hello everybody. We're going to discuss continuity and one-side limits in this video. And we're going to be answering the question, how do we know when a function can be said to be well behaved? And we've mentioned this a few times now when we were talking about limits, but we hadn't really put any definition to it. So, well, time for a definition. We say that a function f is said to be continuous at some point c if the following conditions are satisfied. Number one, that when we substitute in c into the function, we get a defined value. Number two, that the limit as x approaches c of f of x exists. And then finally, number three, that the limit as x approaches c of f of x is equal to the value of f at c. And you can see several examples graphically of when we have a function that is not continuous. So just going down the list right here in our first graph, we see that the limit, this is a situation where the limit as x approaches c exists because the graph's behavior is such that as x approaches c from the left and the right, it exists, right? So it meets condition number two. However, f of c is not defined in this case. So it's not a case where we have continuity. This is called a discontinuity at this point right here, right? Now, on the other hand, we could define f of c, right? And let's say we had a function that was such that our limit also exists. The limit as x approaches c of f of x does exist. But the problem, and f of c is defined, pardon me, I need to get to the problem in a second. F of c is defined. But now it fails to meet condition number three. F of c is not equal to the limit. We get two different values here for our limit, and that's a problem. It doesn't meet condition three. Now, if the limit simply doesn't exist, as it does in this case, right, we say if we were to try to take the limit as x approaches c of f of x, right, once that fails to exist, whether or not the function is defined at that point, then we could say that it's a point of discontinuity at x equals c. The other one, this is another example where the limit fails to exist, right, because of the unbounded behavior of f of x, such as when we have a vertical asymptote in a rational function. We call these points points of discontinuity. So in each of these examples, we have an example of when we do have a discontinuity. So the next question we might ask is, when are we worried about discontinuities and when are we not? Well, functions that we've studied so far include polynomials, rationals, radicals, and piecewise functions. And we've previously stated that p of x, polynomials that have polynomial function characteristics, are the kind of functions where we're not really worried about the function's continuity, because in this case, unless we define something differently for the function, at every point the value of p of x will be defined. The limit as x approaches some value c within every point of this function will be defined, and the two values will equal each other. So polynomials are the kind of functions that are always nice and continuous. Let's talk about r of x. What about rational, or f of x? We've got rational functions. Rational functions are the kind of functions that we should be worried about, because rational functions are the kind of functions where we might find a vertical asymptote or points of discontinuity where we have a hole in the graph, right? So this would be the kind of function that we should worry about. How about radical functions? Well, radical functions, we can say, unless we define them in some way, they might be the kind of functions that we're not so much worried about, although we put a little asterisk right here because we might have to worry about endpoints, and we'll talk about endpoint behavior. right, as something that perhaps we can talk about and discuss. The other kind of function were piecewise functions, and piecewise functions, yeah, we should worry about discontinuities there because we have a function that changes its behavior at a certain point. And so these are the kind of functions that we should probably look at in terms of when do we have a continuity problem that we should discuss. And so we'll do that in the upcoming slides.